Hello everyone. In this video we'll learn how to find the limit of sine by using these two rules. Limit of sine theta over theta as theta approaches 0 equal to 1, and limit of theta over sine theta as theta approaches 0 will be also equal to 1. So in this question here, the limit of sine square root of 2 theta over square root of 2 theta as theta approaches 0, by using the rule, this is going to be equal to 1. Here, it's going to be limit y approaches 0 sine 3y multiply 1 over 4. I need the y here. By also missing 3, I need 3 here. And once you add 3 down, you need also to multiply the numerator with 3 so they can cross out each other, and you did not basically change the original function. So now I'm going to split this. This is a constant. Can move it out. Based on the rule, this is 1, and 1 multiply 3/4 is a 3/4. Let's try this one now. So limit h over sine 3h as h approaches 0. Well, it's very easy. I need 3 here. And since you multiply the numerator by 3, you need to divide by 3. This is basically my constant that you can move it out. Based on the rule, this is 1, and 1 multiply 1/3 is 1/3. Now about this one here, I need to have sine. So what I'm going to do, tangent is basically equal to sine 2x over cosine 2x. And I do have the x here. Now I'm going to split this. So sine 2x over x multiply multiply 1 over cosine 2x. Now I am missing 2 here, right? So I need 2 down. And since you put the 2 down, you will multiply the numerator by 2. Now you can split your limit. Now based on the rule, this is going to be equal to 1. And here you can substitute x by 0. So it will be 2 over cosine 2 times 0 is 0. And cosine 0 is 1. So 2 over 1 is 2. Now for this question here, we are going to do limit x approaches 0. X cosecant is the reciprocal of sine. And cosine 5x here. Now let's try to simplify this a bit. X over sine 2x over cosine 5x. Now you can move the sine 2x down. X over sine 2x multiply cosine 5x. Now you can split your limit, or first you can split the function here. And in order to apply the rule, you need 2 here. Once you multiply by 2, you will divide by 2. And now you can split your limit. Now based on the rule, this is going to be 1, and here you will substitute x by 0, so that's going to be 1 over 2. Okay, now here, so I'm going to say limit x approaches 0, 6x squared multiply cotangent is cosine over sine. Cosecant is basically 1 over sine. So what I'm going to do here, I need sine here and sine here. I can apply the rule. So it's going to be limit x approach 0. First of all, I'm going to take the first sine, so 1 over sine x, multiply 1 over sine 2x, multiply cosine x over 1. What about 6x squared? Well, in this case, I need x here up, so I'm going to take one of these x's here. So I'm using one of the x's, and I need the second one, the other one here. I am missing 2. I do have 6, so I can take part of the 6, which is 2 here, and the rest can go here, which is a 3. So think about it. The numerator is going to be x times 2x is 2x squared, times a 3 is 6x squared cosine x over sine x sine 2x. Now you can split this limit. Now this is going to be 1, this is going to be 1, and here that's going to be, by substituting x by 0, that will be cosine 0 is 1, 3 times 1 is a 3. So the final answer is a 3.
Well, limit of x approach 0, I could easily take x as a common factor in the numerator. Okay, so it's going to be 1 plus cosine x over sine x cosine x. Now you can take x over sine x in order to apply the rule. So going to be limit as x approaches 0, x over sine x, multiply 1 plus cosine x over cosine x. Now you can split the limit, so limit as x approach 0, x over sine x, multiply limit as x approach 0, 1 plus cosine 0, 1 plus cosine x over cosine x. Okay, now we all know that this is going to be 1. Here we are going to plug 0, so it's going to be 1 plus cosine 0 over cosine 0, and that's going to be equal to 1 multiply 2, and the final answer equal to 2. Okay, so the main idea is to try to play around with the function you have, just to try to find the ratio sine theta over theta or theta over sine theta. So the limit as theta approaches 0 should be equal to 1. Let's try the next question here. Okay, so in this question, what we are going to do, we will try also to split. So I need these together. Okay, so it's going to be equal to limit x squared minus x over 2x plus sine x over 2x. And now you can, as x approaches 0, of course. Now you can split the limit. So limit, and you can take x as a common factor also here, over 2x as x approaches 0 plus the limit of sine x over x, and you don't want it over x, you don't want the 2, so you can easily multiply. That's going to be the 2 in the bottom, where you can take it all the way out later on. Here we can cross out the x's, and that's going to be limit of x minus 1 over 2 as x approaches 0 plus 1/2 the limit of sine x over x as x approaches 0. Now, we all know that this is 1, and 1 multiply 1/2 is going to be 1/2. Okay? Now, what about the other side? Plus. Here, you can substitute by 0, so it's going to be 0 minus 1 over 2, and the final answer would be negative 1/2 plus 1/2 is 0. Okay? Next, if I have a question like this, well, here we can do two things. First of all, we can use the double angle formula, sine 2 theta equal to 2 sine theta cosine theta. Okay? And for the numerator, we can multiply the numerator and denominator by the conjugate, which is 1 plus cosine theta. So we're going to do both. Okay? So it's going to be limit as theta approaches 0, 2 sine theta cosine theta, that's the sine 2 theta, and on the top 1 minus cosine theta, multiply 1 plus cosine theta on the top and the bottom. Okay? Now in order to multiply, when you multiply, you're going to get the numerator will be 1 minus cosine squared theta over 2 sine theta cosine theta multiply 1 plus cosine theta. Remember, limit theta approaches 0. Now, we know that sine squared x plus cosine squared x equal to 1. So sine squared x will be equal 1 minus cosine squared x. So I can use this here, which is going to be the limit as theta approaches 0. Sine squared theta on the bottom, 2 sine theta cosine theta. Or let me move it down. So limit as theta approaches 0, sine squared theta, and then here 2 sine theta cosine theta multiply 1 plus cosine theta. Now you can easily cross out the square with one of these signs because there's a multiplication in here. Now the limit, what is left? Limit as theta approaches 0, sine theta over 2 cosine theta multiply 1 plus cosine theta. Well, if you try to plug 0 in this equation, you are going to get sine 0 over 2 cosine 0 multiply 1 plus cosine 0, and that's going to be equal to 0 over 1, which is equal to 0. Okay, next question. What about this one? Well, here we can use, instead of cotangent 5y, we can put cosine 5y over sine 5y, and same with this one. So we're going to use limit as y approaches 0 of sine 3y, and instead of cotangent, I'm going to use cosine 5y over sine 5y, and we have y in the bottom. I'm going to put it here. Multiply. Now the cotangent on the bottom, it's equal to sine cosine over sine. When I move it up, it will be sine 4y over cosine 4y. Okay. Now here I'm going to try to create the, again, we're trying to create sine theta over theta. So for example, I have 3 here. I need to have 3 here, okay? That's what we're trying to find. So first of all, let me put the signs by itself, cosine alone. So limit y approach 0, sine 3y over y, multiply 1 over sine 5y, multiply sine 4y over 1, multiply cosine 5y over cosine 4y. Now what do we need? We need 3 here, we need 5y here, and we need 4y here. Yes? Let's try. If I multiply here by 5y and divide it by 5y, y's can cross out each other. So I'm not changing the original problem. Also, I multiplied by 5 here and I divided by 4. It's like you multiply by 5 over 4. Then in order to do that, you can also here multiply by 4 over 5. So this 4 can cross out this 4. This 5 can cross out this 5. So again, you are not changing the original equation. Finally, what about the 3 here? Well, I need 3 also up. So we said that we are going to multiply by 4 over 5, and then when I need 3 up, that means I'm multiplying here also by 3. So I will multiply everything by 12 over 5. Okay, that's what I'm going to do. So now we're going to multiply here by 12 over 5. Okay, now we are going to split the limit, and we're going to give the 12 over 5 all the way to this ratio. Now limit as y approach 0 for sine 3y over 3y, multiply limit 5y over sine 5y, again as y approach 0, multiply limit sine 4y over 4y as y approach 0, multiply limit of 12 over 5 times cosine 5y over cosine 4y as y approach 0. Well, we all know that this is going to be 1, this is going to be 1, this is going to be 1, okay? Now, what about this one here? Well, you can substitute y by 0. So we're going to get 1 times 1 times 1. And when you substitute by 0, you're going to get 12 cosine 0 over 5 cosine 0, which is finally going to be 12 over 5. Okay? Thank you guys for watching. See you next video. Bye.